Welcome back to Simple Stats for STEM. This video is going to walk us through a t-test. A t-test is a statistical test that compares two groups or one group on a continuous variable. And so we're going to see if there's a difference in the means between two groups, or we can see if there's a difference in the mean for one group being tested two times. And so this video is going to be called, this is a dependent t-test. And so what I've done here is I've created some data for us, and this is the scenario in which we're talking about some math attitude. And the scenario is that we're seeing if there's any statistically significant difference in math attitude for middle school students if they attend math tutoring. So let's say we gave them a math survey, a math attitude survey of some kind, and we gave them that to 20 students. And they got an average. Their scores here have been averaged. There's a mean there and the standard deviation for this set of scores. So they got this set of scores. There's 20 of them, and then we instituted maybe a tutoring program. And after a few weeks, we tested them again on the same instrument, the same measurement of math attitude, and we'll want to see if that math tutoring system is having any change or any effect on their math attitude. And so the mean here is a little bit higher for the after test or the post test. And so we might look at this and say, well, boy, it sure looks like our tutoring program is working. The mean is a little bit higher. Of course, the standard deviation is here, but we might look at this and say, well, the mean went up, but the question is that statistically different from the mean from the pre-test? And so the scenario here is pretty basic and pretty simple. This is called then what we might call a dependent t-test. And this is for if we are using the same participants before and after. So participant 1 got a 12 on the first test. They got a 12.7 on the second. So we are pairing up. You might also call this a paired t-test. We're pairing up the individual with their pre-test and their post-test, and you can ask ourselves, is there a statistical difference? So what I've done over here is the first thing I've done is I've created some histograms, and I cover the process for doing this in one of the earlier videos on normality and histograms. And so if you want to know how to do this and get this output, just watch that video. It's pretty basic. But what I've done is I've taken these test scores. This is for the before histogram. I've taken these scores, put them into bars or bins. This is the frequency right here. And then I've calculated the normal distribution of what the normal curve would look like, and I've placed it here on the graph. And so my histogram of the before scores looks rather normal. Most of the scores are toward the center. And so remember, before we can do these tests, we need to show that the data is basically normal. And so that's what this histogram accomplishes. It shows us how the data is clustered and the frequencies of it. I did the same thing down here with the after scores. And this data here looks a little bit more normal than the before test. It's a little bit closer to the center. But this red line shows what the normal curve would be, and then these blue bars, of course, are the frequency counts for the post test or the after tutoring program scores. So this t-test is a category called means testing. We are testing the means of two groups or one group before and after to see if the means are statistically different from each other. So we can go ahead and run this t-test. It's actually pretty quick and easy test. And so we can do that a couple different ways. The first way I'm going to do that is right here in Google Sheets. And we're going to use, we're just going to come up here and type equals and then t-test. And this will give us the formula for a t-test. This is only going to give us the probability of these measures. It's going to tell us the likelihood that these two groups are the same group or different. And so what I'm going to do is I'll click on that. It's going to ask me for the range. That's for the first group. The range of scores for the second testing or the second group. We're going to talk about a two-tailed test, and then the type we want is 1. And if you want to read up on that more, what those numbers mean, basically the 1 is for a paired samples t-test. There's also an independent t-test, which would be a different type. But we're going to put in here then those values and ask Google Sheets to tell us the probability of these two scores being statistically different. So our first range is the before test. So I'll highlight those and then comma. And then the second range is simply this set of scores right here. And then I'll hit a comma there. It's going to ask for tails. I want a two-tailed test, and which basically means we're looking at both ends of the normal curve, and the type is going to be a 1 in this case. So I'll close that up and I'll hit enter. And right here it gives me the probability of the t-test. This is the significance level. This would be the p-value. And so this is telling me that there is a statistically significant difference between the before and after. And it's saying that there is there's less than a 5% chance that we're wrong when we say that there's a difference between these two means. Now, the reason for that difference, we're going to hope, and if we've set up our scenarios correctly, we're going to hope the difference is due to that tutoring scenario. That has to do with how we've designed our study and what we've done to keep other things from conflicting with it. But this now gives us the right to say, yes, there's a statistically significant difference between the before and after, and we would like to think that it's based on math tutoring. And there's less than a 5% chance here that we are incorrect, and that's nice. So I'm gonna bring that down here a little bit. Normally we look for a p-value of less than 0.05. That's our significance level. And so since this value right here is less than that, we can say that we have a significant finding right here. So that's pretty interesting. Now, this doesn't tell us a whole lot. It just gives us the basic probability of us being right or wrong in our rejection of the null hypothesis. So in this case, we reject this null and we say, no, there is a statistically significant difference. And there's less than 5% chances of us being wrong. Actually, there's a whole lot less than that. We're almost 99% correct when we say that. I'm going to talk about two other ways to do this. The other two ways I like a lot better because it gives us a lot more information. The second way is to use an add-on I've talked about before. That's XLMiner. So this is a free add-on, XLMiner Analysis Tool Pack. So I'm going to start that up, and it's going to pop up over here on the side, and I'm going to go down here to T-test, and I'm going to use the paired two-sample for means. Pairing means you've paired the participants before and after something. So I'm going to use that T-test. And it's going to ask me for similar information here. It's going to ask for the range of the first variable, which is this set of scores right here from the pre-testing. And I'll click the range and pop those in there. It's asking for me for the second range. I'll highlight this range, put those in there. The next thing it asks me for here is the hypothesized mean difference. My hypothesis is that there is no difference between these two sets of data. So I'm going to say my hypothesized mean difference is 0. I want to say that the difference between them is nothing, and so that's my hypothesis. So I'm going to put a 0 in there. I did not highlight the labels, which actually I should have. I'm going to go back and do that actually. So let's clear these out real quick. It just takes a second. I'm going to highlight the labels, put the whole thing in there, and that way it'll be a little more clear when it comes out. So yes, I have labels in there, and I'm going to click down here in this cell and tell XLMiner to put the output in that cell. So then we hit OK, and this will give us quite a bit more information. And you'll see here that the means right here, those are the same, roughly the same means as we had up here. And they're a little bit different because of rounding differences, but those are basically the same means. There's quite a bit of other information here. There's my number of observations, the variance. There's a correlation between the two measures in case you're interested. And then the degrees of freedom, but the real numbers we want here are the t-stat. That is the output of the formula that the t-statistic comes from, the t-test, and I'll actually show you the formula for that in a minute. So that's the t-stat, and then we want to look at the p-value for a two-tailed test, and that is this value right here. And you might notice that is practically the same as this number right here. And so these two tests have revealed the same thing. XLMiner gave us a little bit more information than what we had, specifically this t-stat value. We would need to have that for reporting. Gave us the same probability, and it reaffirmed our means, and that's pretty handy. But these two pieces of information right here are very valuable. And so we have just a little bit more. The third way that I could do this would be to use a website that I've shown you before. It's called socialsciencestatistics.com, and if you recall, it's this website, SOCSCI, statistics.com, social science statistics. And this website I like because it will do the calculation for us and it will show us the formula in some of the math. So on the calculators tab, I'm going to scroll down here to t-test. I went past it for two dependent means. And we call it dependent because we're talking about the same group being tested twice. So dependent means, and then all I've got to do is, by the way, there's the formula. If you want to work it by hand, you can do so. I'm going to go to the calculator, and on the calculator, I am going to put in my first treatment and my second treatment. So I just have to bump back over here to my spreadsheet, get my two columns. There's my first treatment. Pop that in there. Come back over here, get my second treatment. And by treatment, they just simply mean the assessment. I put those in there, and then I need a significance level of 0.05, and I want a two-tailed test. And I'm going to calculate that now. And this is going to now give me all the values that came from that are part of that formula. Well, that's pretty handy. If you ever want to do it by hand, you can check yourself there. And here's the outputs of the formula. So here's our t statistic right here, but it puts it all into one place here. The value of t-stat is 3.28. It's giving us the absolute value, so that's going to be just a little bit different here in a second. I'll compare it to the other two. There's the p-value, and there's the reminds us that the result is significant. So I'm just going to copy that over here, put that onto my sheet, so I have all three of those. And so it's good to be able to compare those. And so there's my same t-stat. And it's the same here. This is just taking the absolute value of that, because really the absolute value is all we really want. So same value, p-value is roughly the same. Again, we got a little bit of a rounding change here just because of decimals and things like that, but it's basically the same number. And then the result is significant. It's less than 0.05. So three ways to find the run a t-test, and this is telling us that there is a probability of less than 5% that we're wrong if we were to say that these two things are not, these two tests are not related. So we would reject this null hypothesis and say there is a statistically significant difference in math attitude of these students when they attend math tutoring. So there's a pretty good example of how to run a t-test for a scenario there. And let's do one last thing. Let's find the effect size. And I'm going to go back over here to the social science statistic, and I'm going back over here to calculators. And on this calculator site, there's going to be a place down here for us to get a p-value. And we're going to, I'm sorry, not p-value, an effect size. I'm going to do effect size calculator. This is going to tell me how much effect there is. And I will do, for now, I'll just do this t-test for independent samples, knowing that I am actually working with a dependent sampling, but I'll just do this for the sake of showing you how it's done. And I'll scroll down here. In my group, if I fill in these values, and then I will get a effect size. So let's see if I can do this real quick. The mean for the first group was, let's go over here, right here, 13.2, 1.38. 13.2. Standard deviation was 1.38. The sample size was 20. For the second group, the mean was 14.4 and 1.27. 14.4 and 1.27, and then sample size of 20. I'm just going to check that number, make sure it was right. Yep, 1.27, and then I'm going to tell it to calculate the effect size. And it gives me an effect here. The Cohen's d is the one that I really want, and there's my effect size. And I will discuss this a little bit more later, but I'm going to just kind of grab that and put that in over here. And this is basically telling me that there is about a 90, there's a pretty good effect between these two groupings. And I'll discuss that a little bit more on another video.